Okay, this is like a suck factor of 30. I've tried to do this 3 times. This is the third time that I'm trying to make this screencast because the first 2 times it deleted it, and I'm not sure why. It's a little aggravating. Let's hope this doesn't happen ever again, or I'm going to have my head is going to explode. All right, so what I wanted to do was to prepare you for tomorrow's lab and also talk to you a little bit about something that will make more sense to you if I tell you now instead of telling you on Thursday. So I'm setting up a set of axes here. Hold on. And because what you're going to be doing in lab tomorrow is exactly what you are seeing here. I will be giving you 3 different liquids, A, B, and C, and you have to test all 3 of them. And you're going to put a small amount, a small volume of that liquid into a really tiny test tube. And then you're going to put that test tube into one of our calorimeter cups, I guess is what you would call them. And that calorimeter cup is going to have some hot water in it. It's not going to be boiling, but it'll be, probably 80 to 90 degrees C. And when you lower that small test tube containing the fluid, whatever the compound is, I'm not going to tell you that yet, into the hot water is actually going to be able to give enough energy, enough heat energy to that small test tube filled with the fluid to allow that fluid to boil. Now, clearly, these fluids are not water. They may look like water, but they aren't water. They're going to have lower boiling points than water, which is why we can boil them in hot water. So what happens here in this process, which is pretty cool, is and you'll have a temperature probe in there that'll be connected to the computer, to LabPro. You're going to see that the temperature begins to go upwards in the little test tube containing the fluid. And then at some point, it's going to level off. It's going to plateau. And what's really fun about this is that point where it's plateauing is the boiling point right there for that liquid that's in there. And the reason why it levels off is instead of the heat energy going towards increasing the kinetic energy of the molecules that make up the stuff, all that heat energy is going towards is breaking the intermolecular bonds that exist among the molecules that make up this compound and moving them into a gas phase. So in other words, all the energy goes into the phase change of the liquid. So you'll have 3 different liquids, so you're going to have 3 different boiling curves like this, and each one of these plateaus will then represent the boiling point for that particular compound. Pretty cool stuff, huh? So let's take a look at a different curve that doesn't just look at the boiling point, but also looks at the other phase changes associated with a compound. And just to test Viddle to see if this is working, I'm going to hit the stop button and then start again. Hold just a second. All right, I really hope this works. Okay, so let me add that diagram that I was just referring to. This is the exact same diagram that you have on the worksheet that I gave for you guys to complete on Tuesday, and none of you got to this, so this will be a good opportunity for me to talk to you about it. What you'll see here is, let me just box up this area right here. Because what you see here is exactly what I was describing here. This is the phase change going from a liquid to a gas state, and in fact that's exactly what I've boxed out here, the area going from a liquid into a gas state. So you see the same situation where the temperature goes up and then it plateaus off as it's moving from liquid into the gas phase. Let me get rid of that box. Good. But you will also see that in addition to showing liquid to gas, I have going from solid to liquid. So we'd have the exact same kind of phase change going on here. And let's just talk about what's happening. So you start off with a solid. It's pretty chilly. And as you give it kinetic energy, or as you heat it up, it gains kinetic energy, and so therefore the temperature increases until it reaches this point right here. And at this point, rather than the energy going into increasing the temperature of the solid, it's going into the phase change. So you're separating the molecules, getting them away from each other so that most of them are still going to be connected, but many of them are going to be disconnected. And as a result, you move into the liquid phase. So all the energy goes into creating the liquid from a solid. And then, once everything's in liquid form, you can start heating up the liquid again. So that means all the energy goes into the kinetic energy of the molecules, and therefore that's reflected by the temperature increasing until you get to this point. And at this point, or the boiling point, you actually then start to have the same exact thing I just spoke of earlier, where a phase change takes all the energy until everything turns into a gas, and then the gas begins to heat up after that. So I just love it because I think this is the coolest thing, that you have these plateaus representing the phase change going from, in the case on the lower left hand, solid to liquid, and in the upper right hand corner going from liquid to gas. All right, so there you have it. This is one of the last things you are going to learn this term in chem. Oh, there is one more thing. Whoops. We're going to be talking tomorrow about two concepts. One of them is called heat of fusion. The other one is heat of vaporization. And in particular, we're going to focus in on what those values are for water. We're going to figure out how much energy it takes to do this process of converting something from a solid to a liquid, and also this process, converting something from a liquid to a gas. And we're going to do it per mole, all those fun things that you guys love to do. All right, let's hope this time this screencast worked.